Hello everyone, welcome to Study Desk. Today we are going to continue our chapter 1, Real Numbers, class 10 from NCERT. Today we are going to talk about Euclid's division lemma. But before going into that, let's discuss some examples. First of all, we are going to divide 17 by 6. So let's proceed. Here 17 is my dividend, 6 is the divisor. So 6 into 2, we are going to get 12. A multiple of 6 which is lesser than 17. So we are going to get the remainder as 5. Now here, what is dividend? The number that you are dividing, 17. What is divisor? That is the number with which you are dividing. Quotient is the result that you are getting after division process. And the remainder is the number that is left out after division. So here, 17 is our dividend, 6 is the divisor, 2 is the quotient, and 5 is remainder. This is our next example. We have to divide 5 by 12. Now here, what is different is the dividend is lesser than the divisor. Now in such cases, what will happen? Since 5 will not come in the table of 12, we have to multiply 12 with 0 in order to get 0 over here, and hence we are going to get remainder as 5. So in this process, we obtain that dividend is 5, divisor is 12, quotient is 0, and remainder is 5. Now let's go through the third example. Here we have to divide 20 by 4. So 20 is our dividend, 4 is the divisor. Now in the table of 4, we get 5 times 20. So 5 is our quotient, and the remainder that we are going to obtain after division process would be 0. With these three examples, let's discuss what is Euclid's division lemma. First of all, what is lemma? It is a proven statement that is used for proving another statement. A lemma is a proven statement that is used for proving another statement. A statement which is already proven to be true and that you are using to prove something else. So we have been learning throughout dividend equals to divisor into quotient plus remainder in our previous classes. What it is? Given positive integers. Remember, the integers have to be positive. A and B, there exist unique integers. It cannot be different integers. There will be existing unique integers Q and R satisfying A equals to BQ plus R. Now what is A here? A is the dividend. What is B? B is our divisor. Q is the quotient, and R is our remainder. Now the condition that is followed here is R is greater than or equal to 0 but lesser than B, which means that remainder is greater than or equal to 0 but it will always be lesser than the divisor. Now we are going to go through all those three examples and write down it in the terms of Euclid's division lemma. First of all, 17 is equals to 6 into 2 plus 5. We can say 6 goes into 17 twice and leaves a remainder 5. In the second example, we discussed that 5 is equals to 12 into 0 plus 5. Now here, observe that the quotient is 0. The reason being, dividend is lesser than the divisor. So this relation holds since 12 is larger than 5. In the third example, we observe that 20 is equals to 4 into 5 plus 0. Now what is different here? The remainder is 0. Here 4 goes into 20 5 times and leaves no remainder. So that is, for each pair of positive integers A and B, we have found whole numbers Q and R satisfying the relation A is equals to BQ plus R, where R has to be greater than or equal to 0 but less than B. So it means that dividend will always be equals to divisor into quotient plus remainder, and the condition is remainder has to be greater than or equal to 0 but less than divisor. Now the final point that we are going to note here is Q, which means quotient, or R, which means remainder, can also be 0. Q or R can also be 0. Thank you so much for watching.